Picture this. You're standing at a concert feeling the bass thumping in your chest. The beat flows through your body, and somehow you're not just hearing the music, you're feeling it. Now, what if I told you that the feeling you're experiencing isn't just about vibrations, but may actually be tapping into something deeper, a way in which your entire nervous system could be syncing with the environment? Sounds wild, right? But stick with me. Today, we're going to explore how the receptors in your skin, the ones you rely on to feel the world around you, might be doing more than just detecting touch. They could be tuning your entire body to the rhythms of vibration, electricity, and even magnetism. And this could have profound implications for our health, our well-being, and even how we interact with the world around us. Our story starts with something that might sound very familiar, the sense of touch. We all know that when we touch something, whether it's smooth, rough, hot, or cold, specialized receptors in our skin send signals to the brain, allowing us to interpret those sensations. But there are two types of receptors I want to highlight today: Pacinian corpuscles and Meissner corpuscles. These receptors are fascinating. Pacinian corpuscles are deep in the skin and respond to high-frequency vibrations like the buzz of a smartphone or the rumble of a distant engine. Meissner corpuscles, on the other hand, are closer to the surface, detecting lighter touch and low-frequency vibrations, like when your fingertips glide over fabric. Their job is to detect the world through physical contact. But what if they could detect more? Here's where it gets really interesting. These receptors are not just passive feelers. They're actually direct axon endpoints, meaning they plug straight into your nervous system. When they detect mechanical changes like pressure or vibration, they don't mess around. They immediately convert those changes into electrical signals and send them directly to your brain. In other words, these corpuscles are like the first responders of your sensory system. And because they bypass layers of processing, they give immediate, unmediated input straight to your central nervous system. But what happens when you expose these receptors to things other than touch, like vibrations you can't feel or even electromagnetic fields? Could they be acting as portals for other types of signals we usually wouldn't associate with touch? Let's dive deeper. We know that Pacinian and Meissner corpuscles are sensitive to mechanical vibrations, but if you think about their structure, especially those onion-like layers surrounding them, there's reason to believe they might also be sensitive to electrical and magnetic fields. Why? Because they are part of ion-rich environments. You see, these corpuscles are embedded in layers of connective tissue, fluid, and Schwann cells, all designed to respond to mechanical deformation. But this structure also contains membranes and ion channels, basically the building blocks that could make them sensitive to external electrical fields. And here's the exciting part. If an electrical field is strong enough, or if a magnetic field induces tiny electric currents through the fluid, these receptors might actually fire off a signal to your brain, even when there's no physical contact. So now we're talking about the possibility of your body not only detecting touch, but also responding to the electromagnetic environment around you. This opens up the door to a whole new kind of sensory experience. Now let's take this a step further. Imagine a situation where you're not just exposed to a single stimulus, but a synchronous signal. Let's say a vibration, a sound wave, or even a low-frequency electromagnetic pulse. Since these receptors exist all over your body, they could potentially be stimulated simultaneously across large areas of your skin. If these signals are in sync, this would lead to a kind of system-wide activation of the nervous system. And because the inputs are traveling directly from the receptors to the nervous system, the result could be a kind of nervous system alignment. In other words, your body starts to move in rhythm with the external signal. We call this entrainment, where your brain and body start to synchronize with an outside pattern. Think about what happens when you listen to music with a strong beat. Your heart starts to race. You tap your foot, maybe your mood lifts. But what if this effect is more profound than we realize? What if your entire nervous system is responding, not just through auditory pathways, but also through these tactile pathways, creating a deep sense of harmony between you and the world around you? This brings us to a really exciting possibility. What if we could harness this effect for therapeutic purposes? Already there are therapies like vibroacoustic therapy, which uses sound waves to stimulate the body, and pulsed electromagnetic field, PEMF therapy, where magnetic fields are used to promote healing. But what if these therapies are working in part because they're activating these mechanoreceptors, aligning the nervous system in a way that helps reduce stress, manage pain, or improve focus? In fact, the more we understand about the sensitivity of these receptors to electrical and magnetic fields, the more potential we have to develop new forms of treatment. Imagine being able to modulate your nervous system with precisely tuned signals, improving mental health, boosting physical recovery, or even achieving a heightened state of focus or relaxation. What I find most beautiful about this theory is that it shifts how we think about our relationship with the world. We're not just passive receivers of information, we're active participants in a constant dialogue between our body and the environment. Our skin, which we usually think of as just a barrier or a shield, might actually be a sophisticated sensor network that tunes us to the vibrations, fields, and forces all around us. Whether it's the thrum of a subway, the hum of electricity, or the deep bass of a song, our bodies might be far more connected to the world than we've ever realized. And if we can understand that connection, we can tap into a whole new level of human experience, one that is literally in tune with the world.